All right, today we'll be going over some practice problems from a trigonometry unit review. This review focuses on converting degree and radian, arc length, as well as information from the unit circle. Let's go and get right into it. Number one says convert 135 degrees to radians. So you use the conversion ratio. So we take our 135 degrees and we're going to multiply by the conversion ratio, which is pi radian over 180 degree. And what happens in this calculation is the degrees units cancel out, and we just have 135 pi over 180. And if you have trouble simplifying that fraction, I'm going to open up my Desmos here, and I'm just going to type in 135 divided by 180. And if I leave the pi factor out, then Desmos can actually appropriately and nicely simplify my fraction, which is 3/4. So I just click this button on the side here, 3/4. So this would be 3 pi over 4. And if you see here, it says write your answer as a fraction in terms of pi. So I already give you the terms of pi for you. So this would just be 3/4. So you would just write in 3/4. So 3/4 pi. All right, number two, convert 8 pi over 6 to degrees. So this is very similar, but we just multiply by the reciprocal of what we just did. So 8 pi over 6. And we're going to multiply by the conversion ratio, which now we're going to have degrees on top, so 180 degrees over pi radians, right? And what happens here is we get the pi factors to cancel. 180 divided by 6 is 30. So 30 times 8 is 240. So 240, and the unit stays, so 240 degrees. So 240. Number three, a circle with diameter of 14 inches and a central angle of 104 degrees. What is the arc length S? So if you're unfamiliar with what arc length is describing, you have a circle, we have a center, and if you cut out a slice of 104 degrees, something like, it might look something like this. If this was 104 degrees of angle, of degrees, something like that, we're trying to find the arc length, meaning what is the length of that arc, which is like a piece of the circumference. The way that this formula works, it's actually a pretty easy formula. It's your arc length S equals R times theta, where theta is your angle and R is the radius of the circle, which, let's talk about that real quick. The diameter was 14 inches, so radius would equal half of that, so 14 over 2, which is 7 inches. So that's 7 inches. Now the problem is you might think, okay, just R times theta, so 7 times 104, but the problem is that's in degrees and the formula is used in radian. So to use the formula correctly, we're gonna have to convert to degrees. So let me rewrite the formula. It would be S equals R times theta, but since theta is in radian and we have a degree, we have to convert our degrees to radians, so we're gonna multiply by pi over 180. And now the formula is in degrees. So now that I've done that, this formula is in degrees. So let me go ahead and substitute all my values. So it's 7 inches radius times my angle, 104 degrees. Technically my 180 should have degrees. And then times pi over 180. And it says round your answer to the 10th place, 1 decimal. So I'm going to type in 7 times 104 times pi over 180 in Desmos. And let's see what I get here. 7 times 104 times pi over 180. And if we round to the nearest tenth, that would be about 12.7. So 12.7. And that's inches, but we're not going to put our units. And again, just going back to this diagram over here on the right, that means this green arc here that I highlighted, the length of that. And you know, in class, I sometimes mentioned that arc length is similar to the idea of like pizza crust. Your pizza crust length would be 12.7 inches long. Number 4 asks us to convert 200 degrees to radians. So this is just another formula where we take our 200 degrees and multiply by pi over 180 to get it into radians. And again, as long as you want Desmos to handle your fraction work for you, right? Because right now we have 200 pi over 180. And if you can't simplify 200 over 180, just go to Desmos, and we're just going to type in 200 over 180. And yes, it'll give you a decimal, but if you hit this little icon on the side, it'll convert to a fraction, which is 10/9. So our answer is 10/9 pi. So just 10/9 would go in this space here, 10/9. Number 5, a circle with diameter of 30 inches and a central angle of 240 degrees. What is the arc length S? So we're just revisiting arc length, so I don't mind doing another example of that. So let's just jump right into the formula. So since we're given degrees and we want to find the arc length, I'm going to have to convert my formula so that it works for a degree. So S equals r theta works for radians, but to make this work for a degree unit, I just have to convert. So I'm going to multiply by pi over 180 to convert my angle into radian. So this will work for degrees now. It would be diameter is 30. So remember, that means your radius is 30 divided by 2. It's half. So my radius is 15 inches. So this will be 15 times my angle, which is 240 degrees, times pi over 180 degrees. Oh, but it says in terms of pi. So what I'm going to do in Desmos is I'm going to multiply all the expression out, but I won't have pi in my answer. So let me show you what that would look like. So the radius is 15. My central angle is 240 times. Now remember, it was pi over 180. So we could just type 1 over 180, right? The pi would go up here with the 1, right? So technically the correct expression would be pi going there. But as soon as you type in pi, Desmos gives you a decimal. So if you just remove the pi, that would be the simplified answer, 20. So the answer is 20 pi. So 20 pi. And that would be inches. But for the Canvas assignment, you're just going to type in 20 for 20 pi. All right, number 6 says convert 2 radians to degrees. So to convert 2 radians to degrees, you have to understand that we're talking about a radian measure. Just because there's no pi doesn't mean it's not radians. Radians just means not degrees. So to convert 2 radians to degrees, you take 2. And we are in radians, so to get it to degrees, we multiply by degree unit and divide by pi radians. So this would actually be 360 over pi, which now we're going to round our answer to the nearest decimal. So I'm going to go ahead and hop on back onto Desmos and type in 360 over. And if you're not sure how to get the pi symbol, you could actually just spell pi, P-I. So P-I. So to the nearest tenth, we would go ahead and do 114.6 would be good. 114.6. Remember, this is in now degrees, but you don't have to put a degree unit. All right, number 7. Kelly is running on a circular track that has a radius of 20 feet. Calculate the angle of rotation in radian measure if she runs 345 feet around the track. Okay, so you got the track, right? And we know that the radius is 20 feet. So it's a circle track, and this is 20 feet. And the question is, calculate the angle of rotation if she runs 345 feet around the track. So what we're actually seeing here is an extension of the arc length formula. So we know that the arc length, right, the distance around the circle, is equal to r times theta. We know that the radius of this track is 20 feet. We're looking for the angle of rotation, and we're given how far around the track she runs. She runs 345 feet around it. So that's our arc length, right? She's running around the circle that far. Theta can be solved for by taking our arc length and plugging it into this formula because we know the radius. So let's see here. So S equals the arc length, which is how far around she ran. So that would be 345. And that equals my radius, 20, times theta. And if we do 345 divided by 20, right, divide both sides by 20, and that'll be our radian measure, 345 divided by 20, because the arc length formula is already in radian. So 345 divided by 20 should be the answer. So the answer is 17.25 radians. And I did give a hint that says every circumference ran would be equivalent to 2 pi radians, right? But just to give you a little conceptual idea of like, what is this answer even saying? Well, every time you run around a circle, the angle of rotation is 2 pi. So if our answer is 17.25, just to kind of give you a way to think about what our answer is even meaning, what it means, 2 pi would be one time around the track. 2 pi plus another 2 pi would be another time around the track, right? That's 2 rotations around the track. And then 2 pi plus another 2 pi plus another 2 pi would be another rotation around the track. And since she ran 17.25 radians, she almost ran 3 rotations because she almost came up to 18.8. She ran around angle of 17.25 radians, so almost 3 times around the track, just to give you some reference. Okay, Kelly is running on a circular track that has a radius of 20 feet. So very similar question. If she runs 1,156 feet around the track, we're going to calculate the angle of rotation in degrees now. So very similar question. We have the circular track. It's the same radius, 20 feet. And we're going to use the same formula. S equals R times theta. And same idea. The amount she ran around the track would be your arc length. 20 feet is still my radius. So 1156 equals 20 times theta, our angle. And then we divide both sides by 20. And theta equals whatever that is. I'll just rewrite it, 1156 over 20. But remember, this is in radian, right? So if I want to convert it to degrees, I'll just do it on the left here. I'm just going to make sure I multiply this by 180 over pi to convert that to degrees, right? Because the degree unit is now on top. That means I am inheriting the degree unit. So in Desmos, I'm just going to go ahead and crank out that whole expression. 180 over pi times my answer to the formula, which is 1,156 over 20. Okay, 180 over pi times 1,156 over 20. And that would be in degrees. 3,311.7. So 3311.7 degrees. And again, every time you travel around the circle, that is 360 degrees of rotation. So if you divide by 360, you could figure out how many times you ran around the track. Looks like it'd be around almost 10 times. Because 10 times 360 would be 3,600. Almost 10 times, close to 9 maybe. Okay, number 9 here. Jeremy bought a pie at Costco that has a diameter of 20 inches. He ate a big slice of the pie, but left the crust. The arc length of the leftover crust is 16 inches. Which of the following radian measures could represent the measure of the central angle? Okay, so we got the pie, diameter is 20 inches, so radius is equal to 20 over 2, which is 10 inches. So that's a 10-inch radius of a pie. And then we know that the arc of the leftover crust is 16 inches. So I don't want to assume I know what the angle might look like, but let's just draw an arbitrary angle. Let's say it's like, that's how much the crust is left over the slice. So that's 16 inches of crust. So our question is, what would be the angle that would make this situation come true? We're back to our arc length formula. S equals R theta. S is the arc length of the crust, which is 16 inches. We know that the radius is 10 inches, not 20, because you have to divide by 2. And there's theta. And we just divide both sides by 10. Actually, not reduce. We'll just get a decimal. It's about 1.6. Equals theta. Now, if you look at the answer choices, you might be thinking, I don't understand why the answer choices have pi in them, and in our workover on the side here, we don't have pi, we just have 1.6. Well, you're just trying to figure out which radian measure could be this theta that we just found. So which one of these representations seem close? So for example, if you look at the first choice, pi is 3.14. So is 1.6 close to 3.14? Not that close. Obviously, you could just head over to a calculator and start asking the calculator what some of these values are. Let me point you to the answer here. If pi is 3.14 and I'm looking for 1.6, that's about half of 3.14. In fact, just to show you here, if you take pi, which is 3.1415, blah, 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 and divide by 2, it's 1.57, which if you round it, it's 1.6. So isn't that close to 1.6? So it looks like I'm looking for pi over 2, which is close to 1.6. If you round to the nearest 10th. So by rounding to the nearest 10th, this is about 1.6. So that's my answer. 1.6, which is about pi over 2. So if I were to redraw the scenario here, it would actually be a 90-degree angle. Because pi over 2 is 90 degrees. It would be something like that.